However, during the ancient era, philosophers were scientists, or more of saying a philosopher was a scientist, and scientists were philosophers. Now, in the time of ancient period in philosophy, where you have the likes of Socrates, Plato, Aristotle, Thales of Miletus, you have Anaximander, Anaximenes, you have Pythagoras, you have Heraclitus, you have a lot of them. These guys were actually philosophers and also scientists, because during that period there was no demarcation between philosophy and science. Science was philosophy. You doing philosophy actually meant that you were doing science, and you doing science actually meant that you are doing philosophy. A good example would be Pythagoras, who today we have the Pythagoras theorem, which is being used in the scientific world. We also have the theory of, that's in the examples now, we have the theory of condensation, which was introduced by Anaximenes, or the astronomical study and prediction of Thales of Miletus and Anaximander. Now, Thales, for instance, was, as an ancient philosopher, is popular for his prediction of the first eclipse of the sun. I know we all know what eclipse of the sun means. He was the first person to predict the eclipse of the sun. Furthermore, we also say that philosophy is the mother of all disciplines, and as such, philosophy plays a major role in the activities of the sciences. Although through its critical, logical, consistent, and tenacious features, philosophy is scientific and science is philosophical. So these are features that philosophy actually work with. And for the fact that philosophy have all these features, which includes critical, logical, consistent, tenacious, systematic, coherent, and so on and so forth, include all these features, it implies and means that philosophy is also scientific, because science also inculcates all these features. And so philosophy is science and science is philosophy. And so we debunk the claim that present-day scientists and some other scientists are saying that there is no business of philosophy in the science. There is actually a serious business for philosophy in the science, and the major of them all is what we're about to do now, which is laying foundations for the scientists to work with, to begin his experiments on. So we have philosophic foundations of science. Now we say that there are sets of philosophical ideas and concepts which the scientists make use of in formatting scientific knowledge and theories. These are sets of philosophical ideas and concepts which the scientists make use of in formatting scientific theories. Here we are trying to answer the question, what is philosophic foundations of science? And then we say that there are sets of philosophical ideas and concepts which the scientists make use of in formatting scientific knowledge. So this means that there are actually some foundations that the scientist must look out for before he starts giving out new knowledge, before he goes into his experiments and then bringing out results. So for instance, if somebody wants to make a tablet that would cure malaria, before he goes into the lab to start experimenting, there are some foundations he needs to know about, and philosophy has given these foundations to be 5 of them. We have 5 philosophic foundations which the scientists must know about. So if I'm to continue from where I stopped, say it reflects the views and general ideas of the scientists in relation to the world, society, individuals, and cognition. Without this foundation, science will become theoretically ineffective. There are 5 philosophic foundations, namely: 1. Ontological philosophic foundation. 2. Gnoseological philosophic foundation. 3. Social philosophic foundation. 4. Axiological philosophic foundation. 5. Anthropological philosophic foundation. So we'll begin with number 1. Ontological philosophic foundation of science. This foundation helps the scientists to understand the intricacies of existence, natural laws, and their workings and manipulations. Now, ontology in philosophy is derived from the major branch of philosophy called metaphysics. Metaphysics is a major branch of philosophy, and it is divided into 2. We have cosmology and then we have ontology. Cosmology is a study of the universe, and then ontology is a study of being. And then you cannot talk about being without talking about the universe, and you cannot talk about the universe without talking about being. And so here, the ontological foundation of science, philosophic foundation of science, helps the scientists to understand existence, natural laws, and how they work. A good example of such explanation, let me continue reading. A good example would be debate. He needs to understand the debate, or the scientist needs to understand the debate of finding a balance between the material objects and ideal ones. If you look at our world today, if you look at the society today, the way our world is being shaped, we understand that the world is being made up. Man, for instance, is being made up of 2 substances: the physical, that is the material, and the spiritual or immaterial. So we all say that man is made up of body and soul, for instance. And so the scientists need to understand that the universe is a composite of 2 substances, that is the material substance and the ideal ones, the ones that you cannot see. So you see the scientists, for instance, making use of terminologies such as waves. I don't know if you've heard of waves, radiation, there's another, what is this word called? Let's use radiation, for instance, and then we have, I can't remember, but it will come. When I remember, then I'll tell you. So the world is divided into these 2 substances, and the scientist needs to understand that whenever he's carrying out his research, he needs to find a way to balance these 2 substances. You have our phones, for instance. We make use of phones to call, and then these phones, whatever you say, travel through magnetic waves. These things, you don't see them. So you don't see these waves, but they are here in our existence. They are part of us. The scientists have understood the use of these waves, these unseen or immaterial objects, and then he has been able to harness them. So, we have the second one, which says change is constant and the unchanging world. If you look at the world today, there are some things that are constant and there are some things that are changing. And then we use the human person, for instance, as an example. Now, when you were born, you were a baby, but today you are already an adult. And then somehow you've changed in your physical appearance, probably in your way of thinking, but the you in you, that is your essence in itself, is still the same. Let's take, for instance, your destiny is still the same. So we say that change is constant, and then versus the unchanging part of the world. The scientists need to understand that as things changes, he should also change. And there are also some things that do not change, and you should also know that there is nothing bad in trying to leave those things that way. If you look at our world today, the scientist is trying, okay, we know that everything, you say everything in the world dies. That's one of a very popular phrase we use, and thus man die. But today the scientist is trying to break that statement. They're trying to create life that can be mortal, no longer immortal. They're trying to preserve human beings, trying to go more advanced in their research. So in doing that, they need to understand that there's a balance between change that is constant and those that are changing. And then we also have the super complex / organized versus disordered system. If you look at the world today, you will see that it is more of unity in diversity. Look at everywhere, everything is scattered, everything is working in a diverse way, but also is still working in that despite working in that diverse way, we still have that harmonious existence there. So you see that the sun will come, and then the rain will come, and then night will come, day will come, and then people die, bombs explode, hazardous chemicals are released into the air. The world is in a chaos, but in that chaos you still have this form of united front. So the scientists need to also understand this, because it's the philosopher that will be pointing out these little things to him. And then we have the world in time and the world outside time. Yes, this has reminded me what I wanted to say earlier in the first one. Now we have what we call quantum physics. It's more like saying physics, quantum, that's almost the smallest part of physics. So unseen part, invisible part. We are talking about the existence of a quantum world. That's a world existing as we are also existing at the same time, in this same earth at the same time, So we have the world in time and the world outside time. Are there possible worlds? According to a philosopher, somebody like Leibniz, he said there are other possible worlds, but this one that we're living in is the perfect possible world that we can actually live in. So are there possible worlds that are outside time? And how do we explain that? How do we react to that in our experiments as scientists? And then the world in time. And then I used to always say that time is constant, and I used to say time is actually God, because God cannot exist outside time, and time cannot exist outside God. So it can actually be a question of semantics to say that God is actually time and time is God, because for God to exist, it means that he has existed in the past, in the present, and in the future, and he will exist in the future. And for you to talk about the past, the present, and the future, you are talking about time, and God cannot exist outside time. And then we can define God to be the basic of the summary of our existence, and we can actually say that time is God. But this is not religion, this is philosophy. So everything in the world is affected by time. Everything is affected by time. But this is not religion, like I said earlier. So let's continue. Dynamic versus static nature of things. I've also explained it in the change in the world. Change is constant and unchanging. No motion without force versus motion without applied force. Now, everything in the world is an effect of a cause. Everything that happens in the world is as a result of an effect from a cause. That is, there must be something that caused that thing to happen. If your car is moving, it actually means that you started the car, and then it's somebody that built the car, So there's actually a cause and effect for everything that happens in the world. But actually, also, that aside, there are also some motions, because for every motion there must be a force behind it. That is, for every movement there must be a force. So, but if you look at the world today, there are also some force that are being applied, but they're not applied by anybody. They're applied by nature itself. So the scientists need to understand that we have at one part no motion without force, and then we also have that there are some motions that happen without an applied force. That is, without somebody applying the force directly to that motion.